All right, welcome back. So transforming cosecant and secant. Not something normally done, right, in advanced functions or sometimes in high school. You most of the time, if you get pushed to the limits, you might be asked to sketch sines, transformations, and cosine transformations, maybe tangent transformations, but not maybe as much cosecants and secants. But I think it's worthwhile to be able to see how you can actually transform these and then what you should think about, because it's actually not that hard under the assumption that you're comfortable with transforming sines and cosines and tangents and so on. So that is my assumption in this video, that you have studied and you understand how to transform sines and cosines. If you haven't, I made quite a few video on transformations. I'll put a link to one of them with regards to sines and cosine transformation. I'll do that up above there. And then the other assumption that I will make is that you're actually comfortable in just graphing the basic reciprocals, right, of trigonometric functions. So you can graph cosecant and secant just on the standard ones, not necessarily being transformed. And for that, I've done a video on how to actually graph those and what to think about. So I'll put up a link up above there. So those are kind of the base parent ones that you graph. But in here, I want to do kind of one example. Now, it doesn't matter. We could have chosen secants, cosecants. We could even go into cotangents, but I'll just do one example to show you, what to think about in these transformations. All right, so let's do it. So we know that cosecant is basically the reciprocal, right, of sine. So it's 1 over sine. Secant is basically reciprocal, so it is 1 over cos. Now, if you extended it to tangent and cotangent, so cotangent is just, again, the reciprocal, right, of tangent. And our interest is going to be, all right, so let's not forget these, okay? And let's take an example, and I'll do this one, which is not really a pretty one to do, but let's do it. And then I'll sketch it. And then we're going to go back to Desmos, right, to try to see, how accurate our sketching actually is. So here's our function, right? So I chose 2 and then cosecant of negative 4x plus 2. And then plus 1 at the end there. So we basically are going to be transforming the entire thing. So within transformations, we know what this should do, right? We have to understand what these two will do and then what this one will do. So there's really 4 things that we know under transformations. We know that there's a transformation which kind of scales, so stretches, okay, or compresses in the y direction. Stretches and compresses in the x direction. Now it can also, do a mirror image, okay, if they're negative. And then there's 2 things in terms of transitioning, okay, to the left, to the right, and then up and down. All right, so doing these types of translations, right? So we have those 4 things that we have to think about. Now, if you were sketching, or at least if I was sketching this, it's not very easy just to start with the cosecant parent function and then start one by one to see what's going to happen. However, okay, so in all transformations, what we do remember is this. So if we did have a function, okay, f of x, and then we had a transformation of this function, so we these are the constants that I use. So we had a, right, which basically stretches and compresses in the y. Okay, then we take the function, and then we had, now I used d in there, so d, and then x minus h, okay, inside there, and then plus my k, where this was our stretch in the, or compression in the x and y, or maybe a reflection as well. This is the stretching and compression in the x, and again, maybe a reflection as well. This h was basically a translation in the x, so to the left or to the right, and this was a translation either up or down. So, what I first will do is I'm going to try to map this up. So this right here, and put it in that format. So if I do that, so this is going to be 2, okay, and then I have my cosecant. I'm going to take out that -4, okay, so that I create a d, and then this is going to be x, it's going to be minus, and I guess it's a half, all right, like this, plus the 1. So here is my a, here is my, d, or whatever it is that you use when you're studying this. Here is my h and my k. So again, the a, d, h, and k just depends maybe which textbook you pick up, which teacher you have in high school. But these are very important things. So that's step number 1. So this isn't anything different than any other transformation that you've done. So now I know my a, I know my d, I know my h, I know my k. Great, but it's still a cosecant. So the next thing that I do is I actually say, well, I'm a little bit more comfortable in transforming. Okay, now cosecant is actually the reciprocal of sine, right? Now, if this was secant, then it would have been the reciprocal of cos. And if it was cotangent, then it would have been the reciprocal of tan. So whichever one of those that you have, okay, so in this case it was the reciprocal of sine. So I'm going to write it out in this way. So 2 sine, and the rest is the same. So there isn't anything else that will change, all right? And what I'm going to do is I'm going to graph this transformation first, right? So I can have a nice, beautiful, one period of my sine function. And then one by one, I'm going to be applying these, okay, to transform my sine, and then extend it. So I'll take one period and then extend that one period everywhere else. That's my goal. And then from there, I'm going to use what I talked about in the reciprocal, okay, of cosecants. And then if we know the reciprocal, so if we have our sine graphed out and we take the reciprocal of it, it's so much easier to graph it, okay? So that's now the next thing that I want to do. So let's take the sine. So I'm going to take the sine, okay, so let's put it up. So here is my x, okay? Here is going to be my y and my x coordinates. I'm going to take, and so here's my sine function. So whatever, actually, hold on a second. Gotta be careful here. So I don't want to make it too big. So let's say something like this. All right. So this is 1. This is -1. So this is just the graph of the parent function sine of x. All right. Now I know my period. So my period is 2 pi. I'm going to keep it in radians right here. So that's my period. So that's the first thing, right? So I'm going to start with my parent function. Now, when I apply, so if I apply, so this in terms of the scaling, so this right here, this 2, so we know what that does, right? So it will scale this thing up. So the amplitude is going to get bigger. Instead of it having 1, it's going to be 2. So I'm going to, slowly start writing this out. So this is 3, so this would have been 2. And then this would have been -2 right here. So this is going to go up to here, right? Come down through the same thing, okay, down through here. Okay, so that's the, that's the stretch that we're having in here on the y. So that's the application of my a. Now I'm going to take, and one by one, so now I'm going to take this, so this -4. So what does this mean? This means some kind of a compression or a stretch, right? Now, this in trigonometric functions, so it relates back that you can actually figure out what the period is. So please don't forget that your period is, okay, so if you wanted to know that your period t is equal to 2 pi divided by, okay, the absolute value of that d. In that d, it is -4. So the negative means there's going to be a reflection, all right, that we will have, which is fine. okay? But it also is going to shrink our period. So our period is going to be 2 pi, and then the absolute value of -4 is this. So it's going to shrink our period to pi over 2. So it's going to compress this thing in. So how it's going to look like, well, so I mean, I'll draw it out here for us, okay? But then I will just show you. So we know, okay, so from here, so this crossing right here, this was pi, right? This was actually pi over 2. This is 3 pi over 2, right? So that's the peaks there. So it's going to take this thing, so this what you see here, so it's going to take this, and it's going to compress it in, so the period is going to get so much smaller. The amplitude is still going to be the same. So how will this look like? Well, it's going to look kind of weird, right? So if I'm going to try to divide this up, in this way. So this is going to go, straight up here, come back, through here. So I'm sorry, it's not going to look the greatest, but that's the compression that it will do, right? And that's pi over 2. Now, I don't want it to be that shrunk because now it's very hard for me to see. So instead, what I'm going to actually do is, okay, I'm going to do the following. I'm going to change my x-axis. But, so I'm just taking what you see there in green, all right, and then just, adjusting my x. So I know that the period is pi over 2. So what I'm going to do here is I'm going to remove these, all right here. I'm going to remove the original one, okay. Let me do that, okay, and then what I'm really, that's not what I wanted there. So what I'm really going to do is, okay, I'm going to say, all right, so this is actually pi over 2, right? Okay, so half of that, so this is going to be pi over 4, all right? Okay, and that is this is my application of D, but now notice that it was, so from right here, okay, there was a reflection, and it's going to be the reflection in the X, so it actually looks, okay, and it goes this way, so that's that, okay, comes back to here, and it's a reflection like so. So that is my A, and now my D applied, so my period has changed. Okay, so now I can, I'm going to remove this. So this is so far. Now what else do I have? Well, I'm going to have to shift this. So now this is going to get shifted. And it looks like it's going to get shifted to the right by a half. Okay, so by a half, by 0.5. So if I'm going to take this whole thing, so I'm going to now shift it by a half. Now, a half, all right, so, well, let's take a look and see what this will be, because we had, we had pi over 4, okay, and I guess this is going to be divided by 2, so this is pi over 8 right here, pi over 8 right here, and then I guess this would have been, I guess this is, so in between, so pi, I'm sorry, I'm just kind of thinking this is going to be 3 pi over 8 right there. So I want a half. Now, so where does that fall? Well, pi over 8, okay, is 0.39. Okay, so that's around 0.4. So 0.5 is going to be somewhere, somewhere along here. So that's the starting point. All right, so this is going to get shifted now. So I'm going to take this, okay, and shift it. So that's the shift, right, of a half. And then it's going to get, so the last thing that I have is this right here, and this is going to go up by 1. So now so I'm going to clean this up. I mean, this is the beauty of being able to, do these things on this tool. So I can take this, I'll bring it down, because if I move it up by 1, okay, I'm going to stretch, okay, this out further. Okay, so now I need, so it's going to be 1, this is going to go up to 3, So this thing, we're going to take it and move it up by 1. All right, so we're going to start there, and it goes up to 3 right there. Okay, there we have it. So that's just one period, right? That's just one period of my sine. And now, so sketching this, I'm going to duplicate this, because this, of course, is now going to go, okay, right here. So that would have been another one. You know, I can duplicate it again, and I can keep repeating this thing in this direction. And then, of course, I can also repeat it, okay, duplicate it. Well, it's going to be a little bit harder to do, but that's all right. And then I can duplicate it like this. So now that's my sketch. So I finished my transformation of my sine. But what was I after? Well, I was after cosecant, not sine. So this is where the reciprocal comes in, and that's where we have to understand, all right, how to actually graph these. So if you remember from the reciprocals and studying reciprocals of these, you know, so what we will do is now we have these points, right? These zero crossings. Okay, so I have these zero crossings all right here. Okay, and so on. And now, so from here, so what we know that the reciprocal at 0, because 1 over 0, so that won't exist. So what I will have is, you know, I'm going to have these lines. So now I'm going to actually plot. Let's see. Okay, so I'm going to take this. Now I'm going to start duplicating it. Okay, right here. Duplicate it again. So that goes right there. All right. Let me take this, duplicate it. So I'm going to duplicate it all of these zeros, and then duplicate it again. Duplicate it again. Okay, and so on. So that's that. All right. Now let me shift the whole thing down. Can. I'm gonna, hold on a second, I'm sorry here. Take this. All right, let's shift it down. So I want to start plotting the cosecant, so I'm going to do that. Okay, so we have this. And now plotting them. Okay, so, you know, how will the, you know, those reciprocals actually look like? Well, so the way that they will look like is, now I can go back. This is just understanding those reciprocals. So we know that they, you know, they touched upon these points, right? If this was my original, and then what happened was that, okay, so they're going to start blowing up in that direction, come back, touch this, and then blow up in this direction again, like that. Right? That's my cosecant. Okay? And then, so, and that would happen on every single point. So here, so duplicate. So this is going to blow up here. And then duplicate, and it's going to blow up over here. All right? And now on the opposite end, okay, so what's going to happen is now, because they're on the negative side, they're going to be blowing up in this direction. So it's going to touch like that. Okay, and it's going to touch like that. And then so on. It's going to be boom. Okay, and we can do that. And what you see there in red is now the actual transformation, all right, of that 2 cosecant -4, x, and so on and so on. So that's how you can actually sketch these. And if it was a secant, you can do the same. Let me pop up Desmos, you know, to show you that it's exactly that. All right, let's graph the two so that you can see that we were, you know, accurate. And those are the steps you can do. You can take this, try it on your own. Make sure you sketch it, because using Desmos is great visually, but when you sketch it, you really understand what is happening in these. So I'm going to pop up Desmos now. All right, so here's Desmos. So I'm going to put, so let's say F1 of that, sorry, of, that's fine. Okay, equals, so I'm going to call this, maybe I'll call this F. Okay, so the first one. So our original, so this is what it was. So I'm going to go back here, 2. Okay, I want to have the sign, so just so that we can see that we were dead on with sketching our sine. So here it is. So I guess we gotta zoom in here a bit. I don't know if I can do this. Okay, give me a second. Okay, so there we go. So notice that's my sine. So it's beautiful, right? So notice where these points are. Okay, so we have these points. And now what we're going to do is we're going to graph. So R, let's see, the cosecant. We'll graph those. So notice it's exactly the same. Boom. There you have it. Look at that. Okay? If I go like this. Beautiful. And that's how you can do those transformations. So if you do have a teacher who's, who really tries to push your envelope here, if you want to get into universities and really start to understand these trigs, I think these are super nice questions, to pose for students. And, once you get used to them and you do, a few, it's so much easier to graph. So my idea is when transforming these, cosecant, secants, and whatever, cotangents, start with the original, right? Transform it like you have done with everything else, because it is much easier to transform sines and cosines. And then just sketch it from what you actually understand about graphing reciprocal parent functions for trigonometry. All right. So I hope you find this example useful. You can now apply it to, pretty much anything that you want with these trigonometric transformations. All right. Okay. Happy studying. Thanks for watching. Cheers, everybody. Bye.